Okay, the first thing that you're going to want to know for the Chapter 8 test is domain and range. This was not on the quiz, so I want to make sure that you guys remember this. Domain are the x values, and for a parabola in this class, all of our parabolas have a domain of all real numbers. The way that we remembered that before was darn. D for domain, all real numbers, D-A-R-N, darn. For the range are y values. So first you want to start with your y, and then you look at your graph. This is a minimum, because that's the lowest point of the parabola. If it's a minimum, then everything in this parabola is above that point, so it's greater than, and it's always going to be equal to, because we have a closed circle right here, and then you pick the number where it is on the y. So this is -1, -2, -3, -4, -5. So y is greater than or equal to -5. Okay, the next thing you're going to have to know for the Chapter 8 test is if a parabola opens up or down. So we're wondering if it's going to open up or down. Remember, you're going to look at the a, which is in front of the x squared. If the a is positive, it's going to open up. If the a is negative, it's going to open down. But the y has to be isolated. So here the y is isolated, and a is positive. So this one is going to open up. In the next equation, the y needs to be isolated. So I'm going to move this -3x squared to the other side, and it's going to become a positive 3x squared. Now, since the a is positive, this is also going to open up. Okay, so the first thing I want to focus on here is vertex. In order to find the vertex, we have to get the x, the axis of symmetry, the x equals -b over 2a, and then we plug that in to find the y. So that's what I'm going to start with. My -b is -12 over 2 times a, which is 2 times 3. -12 divided by 6 is -2. So I'm going to plug -2 into this equation. Remember to use parentheses. And then I'm going to calculate what y equals. So when I plugged in the x and I calculated, I got y equals -3. So now that I have a vertex, I'm able to start graphing. So I'd go to -2 on the x, -3 on the y, and I can make my first point. The next thing you can do is you can graph the y-intercept. The y-intercept is the c value. So on the y-axis at 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, a little off the chart here, but it's fine. I'm going to put my y-intercept. I'm going to make sure this parabola opens up, and it does. This opens up. So my graph is going to look something like this, because it's going to mirror image around that vertex. So really, I'm going up 12 spaces and over 2. So if you kind of rise over run, I'm going up 12 over 2, and I can do the same thing on the other side, up 12 over 2. This is our big spot. I can't say what we called it, but the big spot that we're going to mirror image. And so now that we have 3 points, we can graph. If all else fails and you're just totally lost on what to do, you can always use an XY table and pick any x values like -2, -1, 0, 1, 2. You could plug all of these in, and you could get your values for the parabola and graph your parabola that way. So if you freeze up, you can always use an XY table. Okay, this is zero product property, so for these problems you just set each part equal to 0. And then solve. So if we add 5 to both sides, we get x equals 5. And for this one, we would subtract 3 first, and then we would divide by 2. And so we get x equals -3 over 2. We realized a shortcut on these. If you do the opposite sign here, and then put it over the denominator here, that's a shortcut. So here we would get the opposite sign of -5 is 5 over 1, which is just 5. The next thing for the Chapter 8 test that you'll need to know is how to solve by factoring. So if you look at the first example in red, if I want to factor this, since a equals 1, this is a basic trinomial of factoring. So I need 2 things that multiply to c that add to b. That would be 4 and 2. Okay, and so these would be quadratic equations, so they should be equal to 0. if this is equal to 0, then we can solve each one of these. When you solve them, it's the zero product property. It's going to become -4 and -2. You would just do x plus 4 equals 0, solve to get -4. X plus 4 equals 0, I don't think I said that. Solve that, you get -4. X plus 2 equals 0, subtract 2 from both sides, you get -2. So that's where I'm getting my answers from. The next problem, a is not equal to 1, so I start with the AC method. 2 times 10, which is 20. I need two things that multiply to 20 that add to 9. That would be 5 and 4, so I'm going to split this to 5x plus 4x. Bring down my first and last term, and then I'm going to do factor by grouping. I could take out an x out of both of these, so I get 2x plus 5. And I could take a 2 out of both of these, and I get 2x plus 5. So there's my twins and my GCFs. Now if this were a quadratic equation, we would have this equal to 0. So all of these are equal to 0, and we solve each one of these. When we solve them, I'll do this quickly for you, we get -2 and -5/2. You can solve to check. Okay, these are from 8-7, solving by using square roots. And this is when we don't have a b. So we have like an ax squared, and then we have a number by itself, the c. And so you do this like you're solving for x. If I were solving for x, I would isolate x. Here we're isolating x squared, and then we take the square root of both sides. So I can take the square root of x squared, cancels that squared right there, take the square root of 169, and so x equals positive or negative square root of 169 is 13. You can do that in your calculator if you don't know that by heart. Okay, the next example, x squared equals 10,000. So x squared is already isolated, so now I could take the square root of both. The square root of 10,000 is 100, so that would be plus or minus 100. Okay, for the next one, we need to isolate the x squared, remember. So I could move this -81x squared to the right, so I would add 81x squared to both sides. So now I have 4 equals 81x squared. I then need to divide by 81, and I know that those are both perfect squares, so I'm not even actually going to divide that. I'm going to keep it as 4 over 81, because now when I take the square root of both sides, I can just take the square root of the numerator and denominator there. The square root of 4 is 2, and the square root of 81 is 9. So x equals plus or minus 2/9. Okay, and the last one, so I have to get rid of the squared first. If we have a binomial like this in parentheses, we have to get rid of that squared first. So I have x minus 7 equals plus or minus 1. When you take the square root of 1, you get plus or minus 1. Now I'm adding 7 to both sides. So I have x equals plus or minus 1 plus 7. So I have to do two math problems. The first math problem would be x equals positive 1 plus 7. And my next math problem would be x equals negative 1 plus 7. So my two answers that I get are 8 and 6. Okay, so these are equations that need to be solved. They're already set equal to 0, so that's good. And I can solve using the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. That needs to be memorized for the test. So if a is 2, b is 1, and c is negative 5, and I can just plug into this formula. I get negative 1 plus or minus the square root of 1 squared minus 4 times a times c all over 2a, 2 times 2. Now remember, we talked about in class how there are two negatives here, And so that's going to make that a plus in between. So I've got underneath the square root, I'm going to have 1 squared, which is 1, plus whatever I get when I multiply those numbers, 4 times 2 times 5. So 4 times 2 is 8 times 5 is 40. All over 2 times 2, which is 4. So then I would have negative 1 plus or minus the square root of 41 all over 4. I'm going to calculate the square root of 41 on my calculator, and I get 6.4. I just rounded that number. So it's actually 6.4. And now I can add negative 1 plus 6.4 divided by 4, negative 1 minus 6.4 divided by 4. My final solutions are 1.35 and 1.85. Okay, so in the next problem, instead of doing the quadratic formula, I'm going to just see how many solutions that equation is going to have. Might say find the number of solutions or find the number of zeros that that equation might have. In order to do that, we're going to use the discriminant. The discriminant is just the stuff underneath the square root. No square root symbol, just the b squared minus 4ac. So if I plug my numbers in, b is 4, so 4 squared minus 4 times a times c. I only have one negative, so that's going to be negative, so I get 16 negative. 4 times 2 times 3 is 24. 16 minus 24 is negative 8. Since I got a negative number, my answer is going to be no real solutions. No solutions. The question will ask how many real solutions, so there are none. There's no real solutions. If I had got a positive number right there, I'd have 2 solutions. If I got a number that's equal to 0, then I'd have 1 solution. It's just something that you have to remember. So if you get a negative number for the discriminant, your answer is no solutions. If you get a positive number for the discriminant, your answer is 2 solutions. And if you get 0 for the discriminant, your answer is 1 solution.